There's just no question about it. I used to tiptoe around the subject. If you're growing your grapes chemically, you're not doing it properly, period.
Welcome to the Organic Wine Podcast. Hi, welcome to the Organic Wine Podcast. You know, I don't know if I've mentioned it before, but my goal for this podcast is to use wine to connect you to this amazing planet we live on, to inspire you with interesting people who are doing great work, and to continue to expand your love and appreciation for wine. This interview with Jeff Lowenfels achieves all three of those goals and then some. Among several other things, Jeff is the author of a trilogy of books that should be required reading for everyone on the planet, but especially for those of us who work in or love wine. His books are titled Teaming with Microbes, Teaming with Nutrients, and Teaming with Fungi. Be warned, your mind is about to be blown. If you haven't been exposed to the soil food web, it's likely that everything you think you know about soil and fertilizer and growing plants is wrong. The science, as Jeff lays it out, is so compelling and fascinating that you will never again walk through a field or forest or vineyard without a sense of wonder and awe. And that glass of wine in your hand will become something even more precious and perhaps metaphysical. If you have any interest in producing, understanding, or drinking amazing wine, what you're about to learn is the foundation for all of it. I don't think I'm overstating it by saying that what Jeff has to teach us is revolutionary. Enjoy. Jeff, thank you so much for doing this. I've been looking forward to talking to you, actually, because I think, you know, the subject matter that you are an expert in is really foundational to, this is the Organic Wine Podcast, and I think it's really foundational to wine because the foundation of wine is the vines and the soil and the earth from which it grows. And that's your expertise. I've been reading your books, which I just want to say, in a way, they're kind of revolutionary. I hope that's not overstating it, because they are showing us that the common understanding that I don't know why we've grown up with this understanding about soil and fertilizer and the way plants grow, but we've just had it all wrong.
Right.
And your books are Teaming with Microbes, Teaming with Nutrients, and Teaming with Fungi. And
Right.
And you probably have some other stuff in the works, but those are the ones that they're an amazing revolutionary trilogy that everybody should know as well as they know, like the Lord of the Rings trilogy, for example.
There you go. Gee, I thank you for that. But you're absolutely right. I mean, we were taught wrong. We got it all wrong. I mean, we just were taught wrong, and we were taught wrong because probably we at least me, I was brought up in a time that had a slogan, better living through chemistry. And everybody was very excited in the 1950s about chemistry and science and all the modern things that were going to be coming forth. And of course, what we were doing is we were using the munitions from World War II as fertilizers. The big gigantic munitions industry could convert to a fertilizer industry. That's a great shift, and that's what happened. And I think that was why we practiced what we practiced. Why we didn't do what we're supposed to be doing is because nobody could fathom that was what was going on. The science wasn't advanced enough. Particularly the observational techniques weren't advanced enough for people to really understand what was happening. And until there was a convergence of microscopy, soil science, microbiology, all of these things came together and enabled the science world to finally get a window into what was really happening in the soil and how plants ate and what they did with the food once they took it up. And once that happened, the clarity began to to form. People began to understand the system is a very natural one. It's been going on for thousands and thousands of years, and it is one that becomes not destroyed, but certainly altered by these modern techniques that we all began to adapt in gardening and in farming and in viniculture. So
And that,
uh, let me tell you how the system works, just so that
yeah,
everybody can understand, because I
that
think
that system you refer to as the soil food web, right?
that's right. And
Okay.
just so that everybody knows what a soil food web is, people are very familiar with food chains. A little guy eats the bigger guy, gets eaten by the bigger guy, and that guy gets eaten by another bigger guy.
Right.
That's a food chain, and there are thousands and maybe millions of those that occurring in the soil. So every now and then, what happens is something on one of those chains looks around and sees another chain and says, "Hey, you know what? I could eat that," and grab something from a different chain. And all of a sudden, you get a linkage. And pretty soon, all of these chains link together into an enormous web. And in the soil, it's called the soil food web, which makes a lot of sense. It's really sort of a description of who gets eaten by who poops out who, as life goes on in the soil. So that's the background. That's sort of the stage. We have this soil food web, all these things running around in the soil, eating each other. And it's not just the big things that you can see, the springtails and the worms. It's all the way down to the bacteria and the fungi. And they're running around in the soil doing just what the big guys are doing. They're breeding and they're eating and they're fighting for survival. So that's all going on in the soil. It's this tremendous, crazy event going on. And then you put a plant into the soil, and here's where the science really hits the road. People didn't understand that a lot of the photosynthetic energy that plants utilize is not used to grow a grape or a new vine or a vine tip. It's used to produce chemicals that drip out of the roots. And these chemicals are known as exudates. They're exactly the same thing as the chemicals that drip out of your skin, sweat. So these plants are essentially sweating these exudates out into the soil. And they're full of all sorts of substances that have lots of carbon in them. And that is what attracts the bacteria and fungi to them. And so they drip out of the root. They stay right there in the little rhizosphere, right by the root system, right by those root hairs. And along come bacteria and fungi, and they start eating them. And boy, they're great because it's a higher concentration of carbon than elsewhere in the soil. And so they're eating, they're happy, but along come nematodes and protozoa, which need carbon as well. They get their carbon not from the exudates, but by eating the bacteria and the fungi that are in turn feeding on the exudates. And so they eat the bacteria and the fungi, and they use what they need. Carbon and other nutrients inside the bacteria and fungi are used by the protozoa and the nematodes. And then the protozoa and the nematodes excrete the excess that they don't need. And that turns out to have tremendous amounts of nitrogen in it in exactly the same form that a plant needs to be able to thrive. And so it turns out that by putting out these exudates, the plant is attracting its food. It
Right.
attracts the bacteria and fungi. They get eaten by the protozoa and nematodes who poop out the excess that contains nitrogen in plant usable form that goes into the plant, feeds the plant. What a terrific system. And then you got the bigger guys all the way, that eat the protozoa and the nematodes. So you've got this system. And while they're running around in the soil eating each other and breeding with each other, they're creating soil structure. So not only are you feeding your plants by having bacteria and fungi at the base of this system, Or I should say, not only are the plants feeding themselves by attracting the bacteria and fungi, they are also enabling the microbiology and the biology in the soil to create soil structure. So, the bacteria, for example, produce a slime. You know, when you brush your teeth in the morning, what you're doing is you're brushing your teeth from bacteria, you're taking the bacterial slime off of your teeth. Well, the same thing happens in the soil. And these bacteria produce that slime in order to be able to stick together and form colonies. And that slime prevents the nematode and the protozoa, or makes it difficult for the nematode and the protozoa to get in and eat them. So, but it's sticky. And when they produce it, it sticks to a little particle of soil. And that particle of soil sticks to another particle of soil. And then along come the fungi. And the fungi, they form these long threads. And those threads weave together those stuck together little aggregates, those bacterially stuck together aggregates. And they form bigger soil aggregates. And these aren't little squares, they're irregular. And so when they stick together, you get pore spaces where air can sit, where water reservoir can be created, where the bad guys can be hidden from by the good guys. You know, they go hide, the little guys hide in those pore spaces. And so you get this wonderful, wonderful structure which you need to be able to grow things. And they adjust the pH of the soil, particularly the bacteria and fungi. They act as a buffer. And so you get the right pH in your soil eventually, if not immediately, depending on how much you have, in order to be able to have the plant utilize all of the nutrients in the soil. You know, we've all seen that chart, which what happens when you have the wrong pH, certain things get locked up. And you get very specialized members of the soil food web, like mycorrhizal fungi, which form a partnership with your grapevine and go out and get your grapes water, phosphorus, and now we've got great studies that show nitrogen, and it brings it all back into the plant and feeds the plant, particularly that phosphorus, which gets locked up in the soil and which require the chemicals that are produced by the fungi and the bacteria that associate with the fungi in order to lock the stuff up and make it available to the plant. So this is wow stuff.
It really is.
And then you throw in, and I'm sorry to continue to just ramble on here, but
No, this is fantastic.
then you throw in the fact that you come along with, I'm going to use the word miracle grow, but you know, you come along with your chemical fertilizer and you put it down. Now, what does that do? Well, a couple of things. First of all, if it contains a lot of nitrogen, you know, the plant goes, why am I trying to attract nitrogen fixing bacteria? Another thing that's part of the soil food web. That's a waste of my time, and that's a waste of my energy and resources. And so you stop getting nitrogen fixation that way, or you get reduction in it. Instead of having a great diversity of microbes, which is important because that diversity of microbes not only keeps everything in check. You know, if we were all alligators and there was only, you know, there was one chicken, that chicken would be a dead chicken very quickly. But if there were lots of chickens, you know, they can kind of run around and protect themselves. Anyway, you need diversity. When you put down a chemical fertilizer, certain of those microbes get killed because there's a salt coming on a little single cell thing and it just blows it apart. And certain of them thrive because they love the whatever that fertilizer has in it. But you ruin the diversity. You end up with a imbalance, and so all sorts of bad things happen when that occurs.
And are you also saying it also sort of trains like once you give it to the plant says, oh, I don't need to spend as much energy attracting the fungi and the bacteria. So then if you remove that fertilizer, it's isolated now. It doesn't have any benefit of the microbiology. So now you've made it an addict. It's addicted to that fertilizer.
Well, it's addicted to that fertilizer. And then when you stop giving it to them, or even while you are giving it to them, you have to become the base of this soil food web. You've destroyed or altered greatly the bacterial and the fungal situation. So in order
Mhm.
for the plant to grow properly, you got to do all sorts. So all of a sudden you have to start doing all manner of work, which normally you wouldn't have to do. I watch people and I advise viniculturists, and it's amazing the things that people do as a result of having destroyed the soil food web. Because once that soil food web is gone, then you start ending up with diseases and pathogens that were normally kept in check either by the plant, which was capable of producing whatever it needed to do to produce itself, and now it can't, or another microbe or something that's in the soil that just keeps the guy in check. Now you don't have that, and so you have to start spraying. Once you start spraying, it's a slippery slope because you're not
Right.
just killing one bad guy, you're killing good guys along with it. So all of a sudden, you end up with an industry that requires any manner of chemical inputs. Whereas, when the Vikings discovered the grapes, they were growing just fine without any of those inputs. So it's a real slippery slope, and it's a terrible thing. There is a reason why the organic wine industry is growing. There is a reason why it is becoming a great profit center. And there is a reason why when you walk into a supermarket, you see an entire section of just organic foods. People understand, that the system we're using chemically is not working. It's not working for our health. It's
Mhm.
destroying the soil because you don't get that soil structure. We're losing an inch of soil a year in places in the Midwest. It's just blowing away. Holy crow! What a terrible situation. So there's just no question about it. I used to tiptoe around the subject. If you're growing your grapes chemically, you're not doing it properly. Period.
Yeah. Yep. And so let's dig into some of the details. You talk a little bit about bacterial versus fungal dominated soils.
Right.
And I'm guessing grapes are in the fungal dominated
Right.
category because they're perennial. They tend to
Right.
like
Right.
those kind of soils.
Well, let
So,
me explain how you get there.
yeah.
So when you start with a brand new planet, uh, what you start out with at the beach end of the evolutionary scale, what you start out with are bacteria, because there's nothing for the fungi really to eat.
Right.
Then, the plants drop off leaves and some material starts to develop. And as you get towards that old growth forest, more and more stuff gets deposited onto the ground, into the soil, and you get more and more fungal growth. And so the ratio changes. The bacteria number basically stays the same throughout.
Hmm.
Uh, but when you get to the old growth, you have so much more fungal, like 50,000 fungal to one bacteria. You go, whoa, wait a second. I mean, it's just crazy.
Wow.
Or 1 to 50,000, I guess would be the way to go. But what that means is, well, let me add one more fact. Certain plants, like, let me go back even one more. I'm going to add two facts. There are two kinds of nitrogen that plants consume. Ammonium NH4 plus, and nitrates, nitrite, and plants will live off of both the nitrates and the nitrates and the ammonium, but they like one more than the other. And so you want to give the plant what it needs. And it turns out that if you're on the ecological beginning of that ecological scale, your plants really want bacterially dominated soil. And as you move towards the old growth forest, you increase the amount of fungi that your plants need because the fungal soil produce a different kind, that different kind of uh, uh, nitrogen. And so to know where along that spectrum your particular plant belongs is crucial. Uh, the easiest way to do it for people who are just general is that if something is in the ground for more than a year, it likes fungally dominated soils. And that certainly would be a grape plant. Now, in addition to that, grapes like mycorrhizal fungi. And so, if you can associate them with the proper mycorrhizal fungi, then you've got a great winning combination.
And
And it,
how do we do that? Like, how do we both create that association, foster that association, and then also cultivate a
well,
soil that is living with the right kind of life that we want in our
Uh,
vineyards?
you know what you do is you can well, first of all, your existing vineyard, if you're organic, most probably has a great mycorrhizal setup. Um, your chemical fed may not have a great mycorrhizal setup. And let's talk about the mycorrhizae, and then we'll talk about how you get them. All of the stuff that people have been reading lately about the worldwide worldwide fungal web that's in the soil. The mycorrhizal fungi that associates with a plant most probably is associating not just with that one plant, but with all of the plants in the area. So all of the individual mycorrhizal symbiotic webs, mycorrhizae, connect with each other. And you can connect a grape plant with a marigold plant, so they communicate with each other. They communicate with each other when there are predators in the area, when there are bad things going on. They feed each other. They transfer water amongst each other. So this worldwide fungal web in the soil is incredibly important. Um, and so when you grow wine grapes, you want to make sure that you've got a great infection of fungi, because that way you know your fungus. I mean, your grapes uh, uh, are operating properly in the soil food web. It's a sort of a little confusing. So this is why your old grapevines, particularly if you're organic grower, do better, because they have this phenomenal setup. So
They have
um,
a huge underground network that's giving them. Well,
that's
and that's what I was going to ask you about, some of the benefits you've talked already. Like, so basically, it's like you have the grapevine root, and then you have this huge mass of mycorrhizal fungi that spread out from the roots and extend the reach of the roots essentially way out into the soil and even throughout the whole vineyard, because it connects with other plants, it connects with other mycorrhizae, and
that's
keeps
right.
going basically. So there's this huge transfer, rather than just the root being able to access what's right around the root, it can extend its reach. And that I, I'm just quoting from your book, but you've got increased nutrient supply and uptake, you've got drought tolerance, you have protection from pathogens, and like you've already said, more carbon storage, soil structure. And
Yeah.
I don't know if this applies to grapes, but you mentioned even hormone production. But I know anything that flowers that might have
Well, you get
an
the
impact on.
the whole concept of terroir. Comes basically from the microbes that are in that soil,
Right.
and they can be very different. And literally, over the past 2 weeks, there have been some papers that have come out, some discoveries that are just simply phenomenal. The idea that a mycorrhizal fungi can bring nitrogen to the plant has been known for a long time, but it's always been an organic form of nitrogen that goes into the plant. Now, again, without getting too complicated, certainly covered in my second book, Teeming with Nutrients. Uh, you need to have a charge on uh, uh, the nitrogen in order for it to be usable by the plant. And
Hmm.
this organic nitrogen that goes into the plant doesn't necessarily have that charge. But what they've discovered now is that these mycorrhizal fungi now can inject a nitrate right into the plant. I mean, holy crow. That is really kind of an amazing thing. So uh, it, it's It's just the stuff that people are discovering is just simply incredible. Now, I should know right at the tip of my tongue, Rhizophagus interacetes, or whatever the exact mycorrhizal fungi is. But if you go on the internet, and I think probably an easier thing rather than to list which mycorrhizal fungi you want to have, go on the internet and look up grapes and mycorrhizal fungi. When you talk to your supplier about mycorrhizal fungi. If you have a supplier that doesn't know about mycorrhizal fungi, I'm sorry, get a new advisor. Mycorrhizal fungi feed your grape plants. That means you don't have to put so many inputs into the soil. That means you're on the regenerative agricultural wagon, so to speak. Your
Right.
plants are working the system in order to be able to feed themselves.
And I imagine practices, let's talk about some of the things that are harmful or detrimental, at least to this network, both bacterial and fungi. That I imagine tillage is, I mean, if
Yeah,
if you have this fragile network of mycorrhiza under the soil,
right.
you're just going to break it up and break the connections that are
Well,
made there. So,
yeah, absolutely. I mean, I'd rather let's take the conversation in the other direction. Let's go. Let's talk about the positive things that you can do, and highlight some of the negatives while we're doing it. So when you plant grapes and you rototill, or when you rototill between the rows, then you're breaking up the mycorrhizal fungal network. It'll establish itself, but it takes a while to do that. So there's the debate that we used to have is, should we rototill or shouldn't we rototill? Well, that debate is over. Now the answer is without question, you do not rototill. If you want to plant a grapevine, disturb the least amount of soil you possibly can. Leave the soil food web intact. If you want to get rid of weeds, use mulch, compost, leaves, chipped up weeds from your property. A lot of people in Oregon, for example, growing those great grapes, they complain to me all the time about their blackberry plants that have invaded all over the. Chip those puppies up and use them. Use them as a mulch in your aisles. Put in cover crops, but do not rototill.
well, the other benefit of mulching, right, is that actually is the food of the fungi, right? Like, and the
Well,
bacteria, or at least
not ne-
they
not
start decomposing it, or
not
how's that
necessarily.
work?
Well, you got
Okay.
you got two kinds of fungi. So you have some fungi that break down dead material. That's their purpose. They're not mycorrhizal fungi. They go in and there's a dead branch, and they just take it down and break it up.
Yeah.
And then you've got the mycorrhizal fungi that are feeding plants. Um, they'll take down whatever they need to take down in order to get what they need in order to feed the plant, so that the plant will give it its exudate. That's what it's interested in. Um, Now, some of these fungi can do both, but really, the mycorrhizal fungi are not necessarily what break down the stuff. So, what you need to have are both kinds of fungi. You need the mycorrhizal fungi, and you need to have the decaying fungi. So it's a
Right.
and those are easy. These are sort of ubiquitous. Once you get them, you got them,
But
and they're there. So.
well,
Uh,
it's the number one, I guess, problem or pathogen or issue that vineyard owners have to deal with is a fungus, powdery mildew.
right,
And it's interesting that because of that, we're spraying fungicide all over our vineyards,
right.
which seems at odds with what we want happening in the soil. What do you have to say about that? I mean,
Well,
other than what you've already said, but
sure,
specifically about powdery mildew, is how's that managed in the
sure.
soil food web
Well,
scenario?
let's start at with the 10,000 foot view. If you've got a good healthy soil food web, you have a good healthy plant. When that plant gets attacked, by those spores of the powdery mildew, it can fight it off. That's what plants normally do. That's why not every single plant gets powdery mildew. So a good, healthy soil food web is the first defense against a powdery mildew attack. Now,
Mm.
you can also enhance your soil food web and create aids to the soil food web in what I call and you call the phyllosphere, which is where the powdery mildew attacks, the area around the leaves and stems. That's called the phyllosphere. The
Mm-hmm.
area around the roots is the rhizosphere.
Mm-hmm.
So, what a lot of wine growers do is they'll make a compost tea, an aerated compost tea using great soil or great compost, and they'll spray their plants very early in the season so that there is a food web on the leaves in the phyllosphere that is out competing any pathogen that tries to attack that leaf. And
Huh.
it can be very, very effective. Now,
That sounds amazing.
it
Yeah.
it outcompetes. It outcompetes for food sources. It takes up space. It can hog the stomata. I mean, there are all sorts of things that are so a compost tea, and certainly the first book describes how to make a compost tea. You can also make compost tea. You basically take compost, you feed it, and you aerate it, and in other words, you bubble it in water for 48 hours, and you end up increasing the microbial population, and then you use that to supplement the food web that you've already got. Or you can make a compost extract. You take good compost and you put it in a cheesecloth and you squeeze that cheesecloth underwater for 15 to 20 minutes, and then you're not increasing the soil food web, but you're releasing it from the compost. Remember when I gave the example of the teeth, the
Mm-hmm.
slimy teeth? That's back.
Right.
So in the morning, you don't get up and just wash your mouth out. That doesn't get rid of the slime. You got to brush your teeth. You got to use energy, and so that's what the kneading does. That's what the bubbling does. Um,
Right.
so those are two great things. Of course, compost itself around the plant is great because it fosters a great soil food web. The soil food web activity will bring the goodness of that compost, the nutrients, the life in it, down into the soil on its own. You don't have to till it in. The soil food web does it for you. And I haven't emphasized enough that throughout all of this, the plant is in control. So when the plant gets the signal that it needs to protect itself from that powdery mildew, it changes the exudate, changes the mix of microbes in the soil, and gets what it needs in order to be able to do it, if those nutrients are in the soil in the first place. So,
Right.
and then we haven't even begun to discuss. I told you could hardly shut me up. We haven't even begun to discuss the terpene production inside the plant, which gives the grapes that flavor and this
Right.
uniqueness. Where does that come from? Well,
Yeah.
those terpenes come from the nutrients that are in the soil. Those nutrients are produced or put into usable form by the soil food web. In other words, if it doesn't go through a microbe, it doesn't end up with the right charge, plus or minus, on it, and it can't get into the cell of the plant in order to be able to do any good. So you've got to have those microbes there doing that. And it turns out that there are microbes inside your plant, in on that grape skin, as you well know. These
Right.
microbes communicate with each other via terpene signaling. Whoa. So it's entirely possible that some of that taste comes from the microbes that are actually on it as you eat it. Oh, I can't confirm that, but it just makes my
No,
mind
it
boggle.
Yeah,
But
it's
again,
amazing.
I mean,
Yeah.
so the microbes you've got at your house and the microbes I got at my house are the difference between the Pinot Noir I can grow here and the Pinot Noir you grow there.
Yeah. That's very
Wow.
cool.
Wow.
Let's talk about,
And I'll go, let me, again,
yeah.
I'm
Yeah.
so
Yeah.
sorry. And
No, no.
those microbes and the way they're there and the way they're treated and the soil structure that they've created not only is a great part of the terroir, but your reaction to them are part of that terroir. So that if your soils have a lot of clay in them, you act one way. You treat your plants one way. If your soils drain phenomenally, you water them a different. I mean, so all of this stuff ultimately feeds the plant and results in the quality and the taste and the characteristics of your product. It's all
Right.
based on the soil food web.
So, and I'm guessing since grapevines do love fungi,
Right, right.
that the cover crops you would want the kind of cover crops that also like that also like the fungi.
Well, not necessarily. What I look for in the cover crop is nitrogen production. I want to
Okay.
have a lot of good nitrogen production. So those
Okay.
those clover related plants are what you want to have in there. Boy, I'll
Right.
tell you, there's no more beautiful sight than a vineyard. With a beautiful clover bloom up and down. And I know people, oh, it's a weed. It's robbing the energy from the plant. No, it isn't. Who told you that? What are they trying to sell you?
Good questions. So what does it do? How does it benefit the plant? I mean, does it not cultivate the mycorrhizae?
Well, they have their own mycorrhizal fungi, but you get nitrogen fixation. And
Okay.
and, and nitrogen fixation is well. Let me finish that. It does have a mycorrhizal association. That mycorrhizal association enables the plant, excuse me, to pick up all sorts of nutrients. When the plant dies, those nutrients are returned to the soil.
Got it.
So that's good. It also does the same thing with regard to nitrogen fixation. Some of that nitrogen is fed directly to the microbes, and a lot of that nitrogen ends up in the plant. When the plant dies, bingo, you've got food for the plant and for the soil food web that supports the plant. So you want to have a good cover crop. Plus,
Gotcha. So
plus, as I said, it looks good.
right. So what happens when we're fertilizing? I mean, even if it's not a chemical fertilizer, if we're adding organic matter in the form of compost, like a nitrogen-rich compost, worm castings, or something like that, what are
Right,
we actually doing for that?
right.
Like, what are we
Okay,
doing? What happens with
sure.
that?
It's unfortunate that we use the word fertilizer for that, and I fall into that trap. It's actually not fertilizer; it's microbe food. What you're
Right.
doing when you put down worm castings, and let's hold worm castings to the side, although they're included in this conversation. When you put them down, they are microbe food. They are broken down by the microbes. The microbes can retain the nutrients that they obtain from breaking those foods down in their bodies, and ultimately they become available to the bacteria and the fungi and the plant exudates, and setting the whole cycle runs. When you use a regular chemical fertilizer, that chemical fertilizer, unless it's eaten by a microbe, goes right on down into the water table, down to that Louisiana Delta.
Right.
It's lost. So these microbes and the soil food web have another added advantage in addition to the soil structure, feeding the plant, helping the plant protect itself. They retain, the soil food web retains nutrients in the soil so the plant has them available, or so the fungi and the bacteria have them available. That's the great thing about the soil food web. It's all right there in this beautiful, clean system. So, worm
And is that
casting. Let's just let
oh
me
good.
what I
Yeah.
mentioned.
Yeah, yeah.
Worm castings and compost are terrific because they've got all of the fertilizer bags. Fertilizer bags to me are the bacteria and the fungi, and all of the fertilizer spreaders the nematodes and the protozoa you could possibly want. That's why compost works, and that's why it's in such high demand. When you make your compost vermicompost, when it's made as a result of going through a worm instead of thermally, you
Mm-hmm.
increase nitrogen, phosphorus, sulfur, all manner of nutrients. You increase them. So what goes into the worm is actually the nutrients in that particle that comes out the back end of the worm is got a higher number, a higher percentage of these nutrients. And that's why it's the best compost you can get.
Wow.
So it's terrific. Now, neither compost nor mycorrhizal nor vermicompost contain mycorrhizal fungi. Mycorrhizal fungi is there because the plant sends a signal out, and it's that signal that attracts the fungi, spore causes to germinate and invade the plant. It's the plant that does the attracting. If you don't have plant roots in your soil, you're not going to get a mycorrhizal fungi. There are no plant roots in the compost or in the vermicompost. So you got to
Got it.
add it. You got to add it, and it's
Got it.
easy to add this stuff. You buy it. It's cheap. There are any number of companies that make it that have the right kind for grapes that are specifically for grapes, and you roll your seedlings in or your cuttings in it. You add it to your soil as you're planting. Bingo, you have it. It's there.
I imagine you could like roll your cover crop seeds in the spores as
Absolutely.
well. And you get
Absolutely. And once it's established, it's producing its own spores unless you're coming along with fertilizing as opposed to microbe feeding, with rototilling as opposed to cover cropping, and with compaction. Compaction is something we haven't talked about. Very bad for the soil food web, you can imagine,
yeah.
particularly the fungus. The fungi are very fragile. So when you drive that tractor up and down and up and down and up and down, your kids decide they're going to get that, take that neat little four wheeler and fool around in the vineyard. You're compacting your soil. So you want to have the right tires and you want to avoid compaction. And if you are compacted, aeration is your savior. You might want to aerate anyway, but aeration helps the soil food web greatly.
Great. What do people do for aeration? I mean,
They rent an aerator,
all right. There you go.
or they walk around in their track or golf cleats.
A lot of walking up and down rows. I love that.
Right.
How does this tie into carbon sequestration in the soil?
Well,
What?
once again, the microbes that's what they do. They hold carbon. Uh,
Okay.
that's they eat carbon. That's what they're looking for. But more important than that, mycorrhizal fungi. There's a particular kind of mycorrhizal fungi which invades your grape plants, which invades your cover crops, and it produces about 30, maybe even 35% of the carbon that's in soil. We used to think, you'd add humic acids and fulvic acids, those added soil, carbon, compost adds carbon, mulches add carbon. It turns out these mycorrhizal fungi literally suck the carbon out of the air and put it into the soil. Whoa! So, fulvic and humic acids, 12, 13% of the carbon that's in the soil may come from them. 30% comes from these mycorrhizal fungi. Go out and get them. The world needs them. Yeah, it's terrific. Terrific stuff.
So I love it. So if I understand this right, grapevines take energy from outer space and they convert it into carbon, which they feed to little critters under the ground, and those critters in turn feed them things that they've eaten from the soil.
Right.
It sounds amazing, right?
Well, and then you add one more thing. You add the fact that the nitrogen, which is in the soil, comes from the air and is fixed by microbes. and put into
Ooh.
the soil. So not only is the sun coming from out, where's this nitrogen? What the heck? You know, unbelievable. Now, we've talked about the soil food web, and I'm going to mention the name of my book, Teeming with Microbes, is certainly all about that. But what I discovered as I was gardening and farming and advising people and helping people grow cannabis and grapes and whatever, was that people don't understand what I consider to be the other legs of the stool. And the first one is how do plants, once that food, the soil food web delivers to them, how do they eat that food? How do plants
Mm.
eat? This stupid question, isn't it? How do plants eat?
Yeah.
Only somebody who lives in Alaska, who spends an entire winter trying to figure out what the heck life is all about, would ask that question: how do plants eat? Now, I'm not asking that question as a scientist. I'm asking that as Jeff Lowenfels, who is not a scientist but wants to know these things. I'm a curious guy, and so when I wrote my second book, which is Teeming with Nutrients, it's written in exactly the same way that first book is, which is simply. This may all sound complicated, but I'm one of my trades is garden columning. I write America's longest running garden column, and so I write 500 word. This is what you need to know this week. And I'm writing in a newspaper. I'm not writing in an encyclopedia or a scientific journal, and that's the only way I know how to write. And
Yeah.
so I've got a simple book, Teeming with Nutrients, that's going to tell you what happens with those nutrients. And it's a as mind-boggling a story as the soil food web is itself.
Yeah.
How that stuff gets in, what happens inside that, the numbers alone, the numbers of individual cells in a grapevine is somewhere in the vicinity of 30 trillion. Holy crow. And in each cell, there are 10,000 different enzymes. We're talking in each cell, 10,000 different enzymes, 1,000 at least of each one. Oh my God.
Wow.
What's going on in there? And
Wow.
why would you want to know that? Well, you would want to know that as a grape grower for a couple of reasons. It gives you a much finer appreciation for temperature and what that means to you, a much finer appreciation for what is happening. You will never be able to look at your grapevines again without having, sort of this mythological experience of because you understand what's going on. You understand that food is that you could get into a root here if you were small enough in a canoe. You could travel through that entire plant, going from one cell to another cell without ever going outside of a cell wall. Wait a minute, hold it. I mean, it's just the whole, and you would learn what I think is the most important lesson, which is the law of return. What a plant produces, a plant's supposed to produce so that it can reproduce itself. That's the only reason it produces that grape. It doesn't produce it for me, for you, for the birds to come and eat it. It produces it as a vehicle to deliver that seed, period. And
Mm.
normally what would happen is that grape, that seed, the leaves, any dead twigs and vines, they would all die, fall to the ground, return to the system, the law of return. What
Right.
do? We come along and we pick the grapes.
Right.
Oh, and we take the leaves that fall and we rake them and blow them off. And
Right.
a dead vine, we take it out. We
Right.
violate the law of return. That's not what makes a healthy plant. So you got to know how do we then replenish, or how do we pay the fine for violating this law of return?
Right.
So that's the second book. Then the more I kept working, the more I kept discovering that information on mycorrhizal fungi, which when I wrote Teaming with Microbes, the first edition, people went, they're around and 90% of the plants have them, but they're ubiquitous. And there's nothing we can do to impact them by, we can't. It turned out all this stuff was wrong. And now we're able to grow some of them in a lab and we can sell them and you can buy them. And oh my gosh, and we can see them and we can study them and understand that if you put too much phosphorus in your soil, you don't get them. And so that if you're using Cornell mix, which has phosphorus in it, as your soil base for your scientific studies, you're not going to get the mycorrhizal fungi you want because the plant says, I don't need to do that. I'm getting it for free. So all this stuff was discovered, and I decided, this is 90% of the plants have this stuff. This stuff is so important. It's feeding the plant all this stuff. Got to write a book. So the third book is Teaming with Fungi, and that's the trilogy. And if you read those 3 books, you're going to be a well-rounded person. You're going to be a much better gardener. Your armpits will probably smell better, and you will grow the finest grapes you will ever have. Simple as that. Now, I don't guarantee the second and third book because, frankly, I had to do a little bit of chemistry in the second book, and the third book. We're talking about fungi, and people are freaked out by them. But I guarantee Teaming with Microbes. And if anybody who listens to this podcast gets that book, and it's available along with Teaming with Fungi, I might add, in Audible form. It's also available, I might add, in French, 2 editions, Korean, German, soon to be Spanish, Romanian, I don't know, a couple of other languages. If you buy Teaming with Microbes and you don't like it, I'll buy it back at 3 times the price. So there you go. I don't know any other book out there on the market that's guaranteed this will make you a better viniculturist. Period.
Well, I'm a mycophile, so I love Teaming with Fungi as well. I thought it was
great.
Great.
Good.
I can highly recommend your books for sure. They're, like I said, revolutionary. I think this stuff, you've just laid out the real basics, but when you even get into the details, it's mind-boggling and mind-blowing.
I wish
really
my mother was around to hear that. You know what I mean? But no, I get a lot of credit for that, and every now and then someone will say something like you did, which is way nicer than I deserve. I'm a nasty, terrible person, but it's the subject. It's the subject matter. Imagine, for example, that one day you got on the internet and you discovered that eating lettuce caused cancer, right? You'd stop eating lettuce, right? I'm telling you right now that using these chemicals is the wrong way to garden. There are 3 books that tell you that I'm not lying. There are thousands of books that tell you I'm not lying, millions of papers, and yet people continue to use glyphosate and, oh my God, this and that. And we know this is bad for us. What else can we say? I don't want to get political. I'm on the verge, but
well, let me ask you a question to redirect, because I think this is relevant, and it's something that just piqued my curiosity. It's a smaller question, but a lot of grapes are grown in Mediterranean climates where, especially California, we don't have any moisture, any precipitation for 8 months of the year, 6 months of the year at least. What happens to the soil food web when that happens? When you get these 100-degree days and no rain for months?
Sure. Well, first of all, one of the things that I always find completely mind-boggling is that you really never get dry soil. It may feel dry, but it's got a microscopic coating of water. So there is that microscopic film. Let's call it a film. I like to say, let's call it a film. That film is there, and the microbes live in that film and live off of that film. Some of them, anyway, a lot of them. If it gets 100 degrees and a microbe says, "Oh, this is not for me," it either goes away if it can. Of course, they don't travel very far, um, uh, or it goes into a dormant state,
Okay.
and in that
Got it.
dormant state, it can last forever.
Great.
And then when it gets good, it so. And then, of
Got it.
course, you've got your root hairs and all sorts of things that are probably also living off of that film. And
Right.
yeah, it's pretty amazing stuff. Again, we're programmed these days to think that we've got to be the boss, we've got to be in charge. No, leave the plant and the soil food web to do their thing, and you'll get what you need.
I've got a philosophical fun question for you too.
Sure.
So, I mean, you live in Alaska, so I'm sure this has crossed your mind at some point on a dark winter's eve. You look, I mean, with what you know and the cycle, the amount of energy that is used by all of these organisms to grow and reproduce and feed each other and die, it seems so cyclical. Why wouldn't it just be easier for everything to just remain nitrogen and phosphorus and base elements and never combine into complicated compounds and lipids and bacteria that make larger organisms?
Yeah,
Why? I mean,
it's crazy.
isn't it?
I have the same question. I mean, I not only did I ask that question many a night here in the middle of the winter, but the last pictures in teeming with nutrients, the
Mhm.
last pictures are side by side. One of them is a picture of a cell with its organelles, the mitochondria, the nucleus, blah blah blah. Next to it is a picture of outer space, someplace in
Yeah.
outer space. And when you look at the two of them, you have to. In fact, you look at the two of them and you go, which one's the cell? Which one
Mm,
is outer space?
yeah.
When I used to give talks before the pandemic, one of the talks I gave was on teaming with nutrients. Most of the talks you find on the internet are teaming soil with food web talks, but I gave one talk on teaming with nutrients, which I gave about probably 7 or 8 times. I don't think it's on the web, but the name of the talk was Horton Hears a Who.
Mm,
Maybe this is a great way to leave this conversation. But
yeah.
Horton Hears a Who. We all know that story, and I'm convinced, based upon teaming with nutrients, that we're in Whoville,
Yeah.
and that we're just part of a big gigantic dandelion that some Horton is holding, and he's just part of a big dandelion that a bigger Horton's holding.
Mm,
It's mind-boggling
yeah.
how these things happen. The chemistry that occurs, it is mind boggling. The
Yeah.
properties of water, why it has it, and the uniqueness of it,
Mm,
mind boggling. And all of this is really obviously so mind boggling that I really had to try to break it down in teaming with nutrients. So teaming with microbes, how plants eat, teaming with nutrients, what they do with their food. But trust me, folks, it is a metaphysical trip in addition to sort of an explanation of the science, because
I love that.
it is trippy. And
I
all of
love
this
that.
stuff that's what
Yeah.
wine, so is wine. You
Yeah.
drink wine and you have that metaphysical experience. And once you know how plants eat, that wine was produced as a result of mycorrhizal fungi and the soil food web that it's part of, the metaphysical experience you have as you taste that wine is even better.
Yes.
So how about that?
Well said. I love it. I love it. Jeff, thank you so much. This is
My
fantastic.
my
You,
pleasure.
you you are a treat, and your books are wonderful, and I hope everybody does read them because we need this revolution to happen.
I hope so, and I hope when they buy them, they never lend them to anybody. Make the next guy buy her own.
Yeah, these are just for the top shelf in your on your bookshelf,
There you go.
not to be shared.
Right. Oh, and if you're ever going to be on CNN, or any of those news shows, where the newscaster interviews somebody and the bookshelf is behind him, please put my books there so they're visible. You're a good sport to put up with me, Adam.
No, you've been great. Thank you so much.
My
I
pleasure.
look forward to talking to you and seeing what comes next.
All right. Be safe.
All right. The sponsor for today's episode is Centralis Wine, and that's my winery. I make all Centralis wines from organically grown grapes because I want you to be able to enjoy our wines not only for their delicious flavor, but also because you know that you're supporting healthy agriculture like the kind you just heard about in this interview. Our wines are now available for sale at centraliswine.com. That's CENTRALAS wine.com.